Chemcare module Chemistry 2 SK025 Chapter Hydroxy Compounds Stage 1. Look at the question number 1. Arrange the following compounds in order of increasing boiling point. Explain. Given three compounds AA, BB, and CC. So for AA, we are given ethanol. For BB, propanol, 1-propanol, and CC, 1,2-ethanediol. So before we arrange in order of increasing boiling point, we have to make sure the compound given first. So all these compounds are alcohols that contains hydroxyl group. So all of these compounds are able to form hydrogen bond between molecules, which is a stronger intermolecular forces. However, for AA and BB, there are only one hydroxyl group present, whereas for CC, there are two hydroxyl group present. So of course, when we compare, the compound that having more hydroxyl group will have higher boiling point. So the arrangement of the compound in order of increasing boiling point is AA, BB, and CC. Okay, for the arrangement that are correct, you will get 1 mark. Okay, so why AA has lower boiling point than BB? Okay, it is because BB has more number of carbons, mean BB has stronger intermolecular van der Waals forces compared to AA. Okay, and for CC, why it has the highest boiling point? Because the two hydroxyl group present form more hydrogen bonds between molecules. So for these questions, 3 marks is provided. So 1 mark for the arrangement and the 2 other marks is for the explanation. So the underlined sentences is the keyword that must be present in your answer. Okay, for question number 1B, arrange the following compounds in order of increasing solubility in water. Explain. Okay, again, before we are going to arrange, okay, we have to know what is the factor that affect the solubility of molecules in water. For the compound given are methanol, 1-propanol, 1-pentanol, 1,2-propane-diol. So all the 4 compounds are alcohols, okay, which means all of these compounds are having hydroxyl group, where hydroxyl group is a functional group that contain O and H, okay, where this hydroxyl group can form intermolecular hydrogen bonding with water molecules. So relatively, okay, all these compounds are able to soluble in water. Okay, but the solubility is affected by, first one is the number of OH group present, and the second one is the size of hydrophobic area. Hydrophobic area is the alkyl group of the alcohol compound. Okay, so we have methanol, where it's contain only 1 carbon and 1 OH group. Propanol contain of 3 carbon and 1 OH group. And 1-pentanol contain of 5 carbon and 1 OH group, whereas 1,2-propane-diol contain 3 carbon but it has 2 OH group. So the first factor that we mentioned earlier is the number of OH group. So the compound that having the most number of OH group will have the highest solubility. So 1,2-propane-diol is the most soluble compound here. Now we take a look at another 3 molecules. or compound, alcohol here. Okay, so methanol that has the lowest number of carbon means it has the smallest hydrophobic area. So remember, the smaller the hydrophobic area, the more soluble the compound. Okay, so now we have known the factor, and now we can arrange this compound in order of increasing solubility. So the answer is starting from 1 pentanol, followed by 1 propanol, methanol, and the highest solubility compound is 1,2-propanediol. And again, 1 mark is for the correct arrangement of increasing solubility in water. Now, for another 2 marks provided is for explanation. Okay, so first, we explain for 1,2-propanediol that has 2 OH group. Okay, so 1,2-propanediol is the most soluble to the presence of 2 hydroxy groups, which means that it can form more number of hydrogen bond with water molecules compared to methanol, 1 propanol, and 1 pentanol. Okay, so 1 marks for 1,2-propanediol. Okay, the second point for discussion is the size of hydrophobic area. So 1 pentanol, 1 propanol, and methanol can form same number of hydrogen bond with water. As the molecular size decrease from 1 pentanol to methanol, the hydrophobic area decreases. So the solubility in water increase. So that is another 1 mark for explanation of this increasing solubility. Okay, next question number 2. So for this question number 2, you are given a reaction scheme, okay, that's starting with alcohol, and you are needed to A, draw the structural formula of A, B, C, D, E, and F in the box provided, and also B, give the reagents and condition of 1 and 2. Okay, let's take a look of the reaction scheme. Okay, so the starting that we have at the center here is 2-propanol. Okay, so let's see for the structure of A that you need to write here. Okay, so for A, okay, these 2-propanol react with sodium metal to form A. Alright, so alcohol is a acidic substance. Okay, so basically, alcohol can react with sodium metal, which is a base. Okay, so for the reactions, okay, for the reaction of this alcohol, the OH group, okay, the OH group here will react with sodium metal, okay, to form a sodium alkoxide salt. Okay, so with the same number of carbon, A is CH3, CH, CH3. So what differ here is the OH is now turned into O minus and A plus. Okay, so the alcohol is now become a sodium alkoxide salt. Okay, so don't forget to put the charge for O minus and Na plus. Okay, so 1 mark for question for structure A. Now, for structure B, okay, as you can see, the arrow given here is a reversible reaction, and the reagent for the reaction is CH3COOH, which is a carboxylic acid, and to be specific, it is a ethanoic acid in the presence of concentrated H2SO4 sulfuric acid and heated. So this reaction is basically a esterification process. when we have alcohol and carboxylic acid react together in the presence of sulfuric acid, concentrated sulfuric acid, so the reaction is esterification, okay, where the product form is an ester. So structure of B here is an ester. For the formation of ester, okay, the OH of alcohol, okay, the H of alcohol, okay, combine together with the OH from the carboxylic acid to form H2O. Okay, so the other part will join together to form ester. So what you have to do is just write down the structure of alcohol first. Okay, so the O of the hydroxy group, okay, now combine with the C of double bond O from the carboxylic acid. Okay, so this is the structure of B. Okay, the O combined with this C of C double bond O. Okay, now we have the structure of B. Okay, now for the structure of C. So these two propanol react with PCl5. So this is a substitution reaction. Okay, where the OH group will be substituted with chlorine from the PCl5. Okay, this reaction give a haloalkane. Okay, so with the same number of carbon and the position of OH, just be substitute with the Cl. So this secondary alcohol will give you a secondary haloalkane. So the compound C form is 2-chloropropane. Okay, so for each structure that you have written, you will get 1 mark. Okay, for structure of D. Okay, so for D, the reagent here is potassium permanganate, acidified potassium permanganate. Okay, hot acidified potassium permanganate. So this is an oxidizing agent. So means that these two propanol oxidize to form a new compound here. Okay, so you have to remember that each classes of compound of alcohol will give you different products. Okay, so let's recall the primary alcohol oxidized with strong oxidizing agent to give carboxylic acid, and secondary alcohol oxidized to form ketone. So this 2-propanol is a secondary alcohol. So the oxidation of this secondary alcohol will form a ketone. Okay, so oxidation means remove hydrogen and add apa ni, oxygen lah. Okay, so the H is no longer here. Okay. Sorry. Okay. Kenapa tak buka ni? Okay. Okay, so CH3, the alpha carbon that bearing the OH will undergo oxidation. So it will become a ketone. So 2-propanol will become a propanol. Okay, so for structure of E, okay, now these 2-propanol react with, okay, the reagent given here is iodine in basic medium, okay, in OH solution, okay, heated. Okay, so when you see this reagent, iodine OH, so this is the iodoform test. Okay, this reagent is for iodoform test. So remember, iodoform is to identify the presence of methyl carbinol. Okay, methyl carbinol compound. So as you can see in the structure of 2-propanol, there is a methyl carbinol group where this alpha carbon bearing a methyl group, OH group, and hydrogen atom. So these 2-propanol did contain a methyl carbinol group. So it will give a positive iodoform test, which is a yellow precipitate for the observation. So what happened to this propanol is, okay, the methyl group, okay, will form the iodoform, become the CHI3. Okay, that is the iodoform. And from 3 number of carbon, now it become, okay, from 3 number of carbon, now it become 2 carbon lah. Okay, so CH3, okay, the alpha carbon that bearing the OH will become carboxylic ion. C double bond O, O minus, and the methyl group, okay, apart to become iodoform CHI3. Okay, and for structure of F, okay, as you can see, the reagent here is concentrated HCl in the presence of zinc chloride. So concentrated HCl in zinc chloride, this is actually a Lucas reagent, okay, for Lucas test. So this Lucas test is to differentiate the different classes of alcohol. Okay, so we know that this alcohol is a secondary alcohol which do react with Lucas reagent. Okay, so for Lucas test, the reaction occur is the substitution of OH, okay, the substitution of OH group with HCl from the concentrated HCl. Okay, so from alcohol, okay, it become a haloalkane. So the structure of F is, you just need to substitute the OH with Cl. Okay, and for this Lucas test, the observation for the secondary alcohol is the cloudiness formed within 5 to 10 minutes. Okay, the cloudiness formed within 5 to 10 minutes. That is the observation for secondary alcohol with Lucas reagent. Okay, now for the reagent 1 and 2, as you can see, the arrow is pointed inwards. Means from this propene, okay, from this propene alkene here, propene, okay, react with reagent 1 to become 2-propanol. Okay, so let's revise. Okay, recall back what we have learned in chapter of hydrocarbon, okay, alkenes. Okay, from alcohol can turns to, from alkene, it can turns to alcohol with this reagent, which is H2O, water. Okay, hydration of alkene, hydration of alkene will form alcohol. So for this addition reaction, okay, it needs to follow Markovnikov rules. Okay, remember Markovnikov's rules that said that in addition to unsymmetrical alkene, okay, the more the more positive reagent will be added to the carbon-carbon double bond that already have greater number of hydrogen. So for this addition, the H and OH, okay, the H will added to this hydrogen, this carbon, because this carbon already have 2 hydrogen, and OH will added to this carbon, okay, since it have less number of hydrogen. So from propene, it will form 2-propanol. And for the second reagent here, okay, as you can see, the difference here is, okay, from 2-chloropropane, okay, it becomes 2-propanol. So the difference is the Cl here is replaced with OH, okay, Cl replaced with OH. So the reagent here must be something that having OH in the molecules lah. Okay, so this is a nucleophilic substitution reaction. Okay, the nucleophile. The substitution involve the nucleophile. So the nucleophile here is Cl minus. Okay, substitute with OH minus. So the reagent here is basically a base, dilute base, iaitu NaOH aqueous lah. Okay, we have a dilute base which is NaOH aqueous. Okay, so for each structure and reagent here will give you 1 marks. So here you are going to get 8 marks. Okay, so that's all